Chapter 12.5 Exponential form of complex numbers. Let's remember that complex numbers in rectangular form are listed as a plus bi, or x plus yj, and I put I over here, forgetting that we have to change that to a plus b times j because we use j in the technical trig. That is the rectangular form where x or a represent the real part of a number and y or b represent the imaginary part of a number. Then we looked at polar form of complex numbers. And our polar form was r times the cosine of theta plus j times the sine of theta, or it was written sometimes like this. Okay. Now we're going to look at a third one, which is exponential form. These are all different ways to write complex numbers. It enables us to do different things, such as multiplying, dividing, adding, subtracting, raising to powers, by switching between the forms, because some forms are easier to use one way and other forms are easier to use the other way. And we'll learn that in the next section, 12.6. But for this section, we're looking at page 358. And we're going to do a couple problems here. 358 in your text. And I'm going to start with number 3. And 3 says the following. Express the given numbers, express in exponential form. And we have 3.00 parentheses cosine of 60 degrees plus j sine of 60 degrees. First thing I would want to ask you is what form is this currently in? You have an r and you have your theta, so this is in polar form. Recognize the different formats. Now we're going to change it to exponential form. So let's list what we have. We have r is equal to 3.00. We have theta is equal to 60 degrees. Now, in exponential form, theta must be in radians. So we're back to changing between radians and degrees. And you can use your calculator to do that. We did do that for a while in our class. Or you can do it the long way, where you take 60 degrees over 1 times 180 degrees and pi radians on the top. Work that all out, and you're going to get pi over 3, which is equal to 1.047197555. And we're going to round it to 3 significant digits because we have 3 significant digits here. And this is kind of iffy. Again, your book changes off and on in that. They do different things. But from what I can understand, we're going to go with 3 significant digits, which leaves us with 1.05. So to write an exponential form is always r times e. E just represents a number in math that's used a lot. It's this big long decimal. You don't really have to understand it much more than that at this time. And it's raised to the j times theta. So we get 3.00 e to the, what's our theta? 1.05. And we need a j. And that is it. That is our exponential form. So this seems fairly easy. Let's try another one to make sure we have this. Number 7 in your book says express this in exponential form. 375 times the cosine of minus 95.46 degrees plus j sine of negative 95.46 degrees. I would ask you what form it currently is in, and you should know or recognize that this is in polar form because we have an r and we have our theta. So let's list that to make sure we write everything down so we don't get confused. R is equal to 375. theta, you can see, is a little bit weird here. It's negative 95.46 degrees, which causes a little bit of a problem, but we're not going to let that get to us too much. Okay, so we have to change this to radians. So change theta to radians. To do exponential form, we have to have theta in radians. So again, use your calculator or the long way. Over 1 degrees times 180 degrees and pi radians. And we get here negative 1.666091,304. We're going to go to 4 significant digits because they list this as 4. I think you take the highest number of significant digits, which gives us 1.667. Whoops, sorry, 1.666. Okay, so now our theta in radians is negative 1.666. Okay, so let's write our exponential form. R to the E, R times E to the J times theta is equal to 375. Sorry, in your textbook they have a 0.5, so I apologize. I'm going to have to add that there. 375.5 e to the negative 1.666j. Okay. Now, something I want you to understand about this. If you look at your we have to remember where this is going to. No, we don't have to do anything. Never mind. This is going to be our answer, and we're not going to overthink this one. Okay, let me try another one here if we have time. We do. Okay, number 9. Let's change colors and go back to green. 9 is listed as 0.515, and then we have the old 198.3 degrees. Again, what form is this in? It's like this, number 7, but it's written differently. It's still polar form. And what do we know about it? We know that r is equal to 0.515, and we know that theta is equal to 198.3 degrees, which we need to change to radians. And if you change that to radians, you will get theta equals 3.46098707. We're going to go to 3 significant digits. Who knows why? I would have thought we would have gone 4, but your book does 3.46. And so when we write this in exponential form, we have r times e to the j times theta. So we have 0.515 e to the 3.46 j, and that is our exponential form. Okay, let's try one more. Number 15. 15 lists 3 minus 4j. What form is this in? This is in rectangular form. And we need to change it to exponential form. Okay. So we start with x is equal to 3, and y is equal to negative 4. What will r equal? Because we have to find r. R will equal the square root of 3 squared plus negative 4 squared, which equals the square root of 25, which equals 5. So we have our r. R equals 5. Okay. Now we take the inverse tan. Remember this? No, I'm having all kinds of problems here. Inverse tan of y over x, which equals inverse tan of negative 4 over 3. and that's going to equal negative 53.13. Okay, and that equals, we have to find what angle that is. For some reason, the way your book lists the answer, we need to try to find out what angle that is. We have theta is equal to negative 53.13 degrees. Okay, so if we think about this, x and y, we would be going 3 and down 4. So we're looking at this angle in here. Because x is 3, y is negative 4. So if we have a negative 53.13, this angle here is negative 53.13 degrees. So how are we going to figure out what this angle is? We would take 360 minus 53.13, and we would get 306.87 degrees. That is what we then need to change to radians. So we have theta. We first had to express it in a positive angle, which is 306.87 degrees. Now change that to radians, and theta in radians is equal to 5.36 radians. So now our exponential form is r e to the j times theta. So we have r is 5. So we have 5 e to the, what is our theta? Theta is 5.36 j. So the only difference in this problem was when we had a negative angle, we had to first change it to a positive angle and then change it to radians. Okay, hopefully that gives you an understanding of finding exponential form, and you'll be able to look at some of the other problems in that chapter and check them in the back of the book. It's not too difficult. This exercise should be pretty easy for you.